Hello viewers, welcome again, and in this video we are going to find the transfer function of an electrical systems, that is for the given network. So in order to find the transfer function of this network, first of all we have to know the S domain representation of certain elements. For example, if you take a resistor, the T domain representation here, and I am writing S domain representation here. So the S domain representation also will remain same for the resistor, and if you consider the capacitor, if it is see here in the S domain representation, it is represented as 1 by Cs, and if you take an inductor L, it is represented as S into L, where you can write S equal to j omega. How this is obtained is, if you write the transfer function, the energy storage elements will depend on the frequency at which the circuit is operating. So by doing these, you can get these. How you got this in the network analysis videos, I will do that again. And to write or to simply convert the transfer function of the electrical systems, you have to convert each element in its S domain, and then you can write the transfer function as Laplace transform of output by Laplace transform of input. So if you initially convert the elements in the S domain, then simply you can write the output by input in terms of S, that is V out of S by V in of S. So here the value across the capacitor is the output voltage, and here we are giving the input supply. So simply for 1 microfarad, I can write S domain representation as 1 by Cs, that is 1 by 1 micro, that is 10 power minus 6 into S, which is equal to 10 power 6 by S. Similarly, I can write for inductor as S into L, that is 10 power minus 3 times of S, and here simply you can write it as 10 cube, because for resistor the S domain representation is R itself. So now simply you can write output by input as V output equal to input times of this resistor, since you can write this as one impedance, and these two are in series, you can observe. So simply here, if you want the output, then you can write V input into this resistance by total resistance. So instead of writing V input this side, I am directly writing this side. So I will get the transfer function directly, which is equal to 10 power 6 by S by 10 power 6 by S plus 10 power minus 3 into S plus 10 cube. So if you simplify this, then you will get the transfer function of the system. So simply now you can solve this by taking the LCM, that is 10 power 6 by S by 10 power 6 times plus 10 power minus 3 times of S square plus 10 cube of S. Since the LCM is S and by S, so if you cancel these two, then you will get 10 power 6 by 10 power minus 3 S square plus 10 cube S plus 10 power 6. Now if you divide with 10 power 6 on both sides, that is for numerator and denominator, then these two will get cancelled. So the final answer is 1 by 10 power minus 3 by 10 power minus 6, that is 10 power minus 9 S square plus 10 power minus 3 S plus 1. So this is the transfer function of the electrical network given. So now from this we can write a note point that the number of energy storage elements present in the circuit is equal to the order of the equation or order of the transfer function. Here you can see the order of transfer function is 2. The number of energy storage elements, since we will not call resistor as energy storage elements, here inductor and capacitor are the two energy storage elements present in the circuit, and the order of the circuit or the order of the transfer function is also 2. So one more note point that one should note it is, this can be stated only after the transfer function is in a reduced form. The transfer function should be in the reduced form only to apply this rule or to state this rule. So in the next video we are going to discuss about the sensitivity, which is one more important relevant topic, that is sensitivity of a control system. So to know the sensitivity of the control system directly calculating, one should know what exactly the sensitivity of a system means. So if you know what the sensitivity of a system, then you can get the feel of finding the sensitivity of the system and how it will affect the system. So sensitivity of a system is everyone want the system that is to be designed in such a way that the output of system should depend on input. So if the output of the system is not depending on the input applied, then no one wants to buy such type of systems in the market. So the sensitivity of the system deals that if the input of the system is changing, then how the output is varied. If the output is varying rapidly such that it is not much efficient in some cases, then the sensitivity of the system is the concept that we are going to explain how due to changes in the input or due to changes in the components of the system, how the output is going to be varied. So with this field of sensitivity, we are going to discuss what exactly is the sensitivity and how it is changing due to the open loop transfer function g of s and due to the feedback of the system h of s, how the value is changing in the next video. So that's all for this video, and see you in the next one.